This
Actually,
conference will now be recorded.
we have completed the rolling update and recreate strategies. So we need to see the other kind of strategies. Let me share my screen. I hope my screen is visible. 1 second. Yeah, I think my screen is visible, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah, the different other type of strategies is called what we need to see is blue green. How the industry blue green type of strategy. What in this strategy, what it will happen is like we have one version of the application like this. Okay, upon that pods, these are the pods. Upon that pods, there will be a service. Okay, SVC, and this service will be routing the traffic to particular pods actually, and these pods belongs to version V1 actually, version application version V1, app version V1, and there will be another service. Uh, 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 there will be a pods again under that service, like this. Okay, this service routes the traffic to that pods. Okay, these pods belong like these pods will be application version V2 actually. So this is kind of blue-green type of deployment. This is blue, and this is green type of. So in this case, what will happen is actually the actual traffic which is coming from the users will be reaching the old version itself. Okay, who are the testers as well as QA people are there? They will be sending the traffic to this service, QA and testers will be sending the traffic to this service, and they'll be testing this application. Okay, they'll be testing this application like this new version of the application. Once they tested, the actual traffic will be routed to this like this. Okay, after the testing, uh, actual traffic, so like this. So this is kind of a blue green type of deployment. Okay, so let's go and see in practical. Okay, it is that. Okay, where I'm in PWD. Okay, I'm in workloads, dot strategies. Okay, and let me go here. I have a blue green type of strategy folder. Okay, CD blue green type of strategy folder. I have three things. Let me show you here. Where is that? Blue green type of strategy. Okay, one is the service configuration file. Okay, one is the service configuration file. This is the blue app which is contains the version, different version which is latest here. Okay, Nginx, if nothing is given, that means it is latest version. And this is a green app which is a different version of that application, Nginx application, stable and Perl. Okay, we have labeled, just observe, we have labeled the new version as type new web app. Okay, this is a label, and this one is type web app. Like here, what is that? 1 second, new web app. This is one new web app, and this one is type web app. So these are the labels that we have mentioned, and in the service, we have selected the type as web app. That means the traffic will be routed to only blue application as of now, because the service we have given the selector type as web app. Okay, let's apply this. Okay, let's apply this in the Kubernetes cluster. 1 second. Uh, okay, let's verify whether anything pods are there or not. kubectl get pods. Nothing is there. kubectl get svc, and only one service is there. That is the default service when we created the cluster only. I'll tell you what is that. Okay, clear the screen. Nothing is there. Now go to, I'm in that one, app service, and I'm in that folder. Okay, uh, PWD. I'm in the blue-green type of strategy. And let me apply that. kubectl apply -f dot. All the files in this directory will be applied. What is that? My app is invalid. Invalid value, labels, new web app, match expression, field immutable. Okay. What's the error here? Let me check that 1 second. Blue app, and this is my app, and green app, this is also my app. Just observe uh, this case of debugging. Okay, if you see blue app, name is my app. Okay, name is my app, and the green app is also with the name my app. So the deployments with the same name should not be present. Okay, uh, that's the reason actually. New, my app new. I'll placing like this, and let me apply this. Apply -f dot. It has been created. Okay, kubectl get pods. Okay, now all the pods were running. These pods were belongs to new application, and this pods belongs to the old application version v1, and this were version v2. And our service kubectl get svc get svc. Our service is this. Okay, my service -lb. Okay, copy that. Just describe it. kubectl describe svc, this one. If you describe what is the type here, it's a cluster IP. What is selector? Selector is type web app. Type is equal to web app. That means the traffic will be routed to this one. The traffic will be routed to this one actually. How I can show for you is, let me, I cannot show because this is a cluster IP. It is not exposed outside. Uh, yeah, generally the industry does like this. 1 second. Let me uh, move this type to node port. 1 second. In that way I can show or not. Let me check whether I can show in that way. Okay, node port, copy it. Now kubectl -f dot. Okay, now what you'll do, get the pods, kubectl get pods, type it. Okay, what I'll do for the simplicity or time saving purpose, I'll making the replicas only one. Okay, the new and old also one. Okay, only one replica that I need to deploy in the cluster. Kubectl apply one dot. Only one replica will be there. Kubectl get pods. Now this is a old application. This is a new application, right? What we'll do, we have configured the service as node port. Okay, I hope you people know what is node port. Previously we have discussed in previous class. Get svc, you can see here my service -lb is node port. Okay, that is routed to on the node 32,481. Okay, let me copy the IP address, or let me check on which node this pod is been running. Let me check that. kubectl get pods -o wide. Okay, uh, this first pod is running on the node 172.31.46.107. Okay, that's a private IP address. 1 second, let me check in the AWS console. 172.31, this one 46.107, 172.31.46.107. This is the one on which my application is running, Nginx. Let me copy this public IP, copy it, and copy in the uh, new tab, colon. What's the port? Port is where is that? 32,481. Okay, 1 second. 32,481. Just click on it. You can see the Nginx application. This is an old Nginx application. With the latest tag. Okay, with the latest tag, we are able to see this. Okay, now let me modify this service, or before modifying the service, what I'll do, I'll log in into this container, this pod. Just this is the first time we are seeing how to log in. Just see that we have used, in the case of Docker, we have used Docker exec-it container ID and /bin/bash, right, to enter into the container, right? In the same way, how to enter into this pod is like this. Okay, kubectl exec-it and exec, right? Sorry, exec-it and this one pod name. Okay, pod name and what I'll say /bin/sh. This is a way you need to log in into the pod. I'm inside the pod actually. You can see I'm inside the pod. I can see this hash symbol. That means I'm inside the pod. Now, from where you are getting this web page inside if inside the container or inside the pod, from where you are getting this web page. This is a web page. It's a HTML page. From where you're getting this is from this path actually. Let me show you. Clear the screen. Let me clear the screen. cd let me put it ls. This only for nginx, it will not be for everything. Okay, slash usr. Okay, sorry, let me go here and that will be a share. This is another folder. I'm inside the share and go to the nginx and html. I want to change that web page. What I'm see in order to differentiate between the new one and the old one, I want to change this website actually. This web page. I want to change this web page so that you will be very clear. That's the reason I logged into the container. Okay, that means I logged into the pod. Now this is a HTML page from which you are getting that web page on the browser. Cat index.html. One second. So this is a HTML page like welcome to Nginx. This is why you are getting this web page here. Welcome to Nginx like this. Now I want to change this HTML page something to let me change this echo some text I want to give test new app. Okay, and index.html. Now just verify it whether it is updated in the index.html or not. Now it is updated. Okay, it is updated. Now come out of the container, or pod. Now verify it, kubectl get pods and pod is running, and update the service, or go to your where I can say is go to your manifest file, go to the service and give web app new. What is this new web app, right? So go there and give selector as new web app. That means it will be routing the traffic to the green deployment. Until now it is routing the traffic to this one with this latest nginx, and now it will be routing the traffic to this green deployment, this one. Okay, now what we'll do, kubectl apply -f dot. Okay, now it is configured, and now what I'll do is let me get the node on which my pod is running. Get pods -o wide. Okay, this is 172.31.43.7, and the worker that is the worker node 2. Where is that? Yeah, this one. Yeah, 172.31.43.7. Copy it, public IP address, and go into the new tab and go here and give the what is the IP address that is been there is get service 32,481. Okay, 32,000. Once again, this is also same or not? Yeah, this is 32,481, or this one 32,481. Okay, you can see the updated one is test new app. Okay, we have logged into the container and we have updated the HTML page there, and we can able to see the traffic here. In such a way, in the industry, what they'll do in order to deploy, if they wanted to deploy blue-green type of deployment, they create the new deployment and the new service, or the existing service. They route the traffic from the existing service to the old way, old version, or the existing service to the new version. In that way they will be routing the traffic. Actually, this is called blue green type of deployment. Any questions with this, please?
But every time we need to change the service, sir. Suppose in the old selector label we need to give, and new selector label we need to give in the service. Dynamically
Yes,
it
yes,
won't
sir.
happen, sir.
No,
In
no,
the service.
dynamically it won't. Dynamically it won't.
Okay, sir.
because
In that case, we need to.
service,
Mhm,
yeah, yeah,
mhm.
anyway, service you need to change because that's where your traffic decides actually which pod or which deployment should be going the traffic to.
Okay, sir. That means manifest files are two manifest file for the pods and for old and new, and service is only one, sir. But
Only
right, sir?
one,
Am I right?
yes. Yes,
Mm.
yes, yes.
Okay, sir.
You'll be changing the selector, whether you want to route the traffic to the new one
Mm.
or you want to traffic to
Profit to the.
route the traffic to the old one. Yeah, like that.
Oh, yeah, yeah.
Yeah, this is the blue-green type of strategy. Okay. Now,
And
before entering to the, yeah, tell me.
one more question. So right now, if we are if we are using the blue man, whatever the ML file service parts, at the time production will
Mhm.
be down or what?
Production will not
So
be done because we are see Kubernetes follows rolling update kind of thing. If you deploy any deployment or not, it will follow rolling update. Like if we update one thing, it will not update make the all other applications down. It will update one by one like that until and unless you specify the like recreate or what like that.
that I understood, but here we are going blue green, right? So right
Yeah.
now only one service is there. So here the example
Mm-hmm.
only we have one service, one blue, one green.
Okay. Yeah.
So green means it's a production, right?
Yeah. Yeah.
Or
It's
what?
a real. It's a updated one. Yes.
Okay. So right now, let it be hypothetical. Right now, one application in the production. Right now,
Mm-hmm.
some changes happen. So right now
Okay.
changes happen means blue and green is the latest one. So we have one
Mm-hmm.
service.
Okay.
So first time I will deploy right at the service because it won't affect the existing production parts or what.
Okay. Yes.
So first time it will just point to the QA. I mean blue,
Okay.
right? So okay, we will do the testing. After that we change to green, right?
Yes, yes, actually. No, no, no.
Yeah.
Actually, what will happen first, testing and everything will be done on green, a new version. Okay. The all the actual traffic will be routed to the old version. That means blue. Okay. Once the
Okay.
testing is done on the green version, okay, by using the selector type, the traffic we will update this selector type, and the traffic will be routed to the new version after the testing. It's
Okay.
a negligible time of change actually.
Okay. Fine.
In this
Yeah.
time, there is a downtime, sir. Might be like suppose while doing like a changing like a service type, selector type. There may be
Mm-hmm.
downtime for the application, sir, for the pod.
Yes, yes. There will be a some downtime, like the
Mm,
downtime.
mm,
If you speak about downtime, what I can say, if
mm.
suppose, uh, one second, this is the old version of the pod, and this is a new version of the this is a service upon that pod, and this is a new version of the pod. One second, this is a new version of the pod. There is a request. This is the first request. First request. This first request has entered this service and it just entered new version. Okay, it's just entered new version of the old version of the this is old sorry old version of the application, new version of the application. Now it just entered the old version of the application. Okay. Now what you did? You routed this traffic to this one without completing this traffic. Now, like this first request, it did not complete actually. I know you updated this service to the to the new version by using type as different label.
Yes, sir. Yes.
Now this will be affected. Okay, this will be affected.
Okay, sir. Okay. Mhm.
Yeah,
That means while changing, sir, while changing, it is moving to
while
the new one.
changing. Yeah, new
That
version.
time downtime.
If you move that one, yeah,
Internally, it is used like a rolling update only, sir. Internally in the pods.
yeah. See,
Uh, uh,
See,
mm.
generally people uses that rolling update only. They'll not use the blue, green or canary until and unless the specific requirement is there. A rolling update is the best strategy that the industry uses actually one by one, one by one.
Link update is different from the blue green, sir, right? That is the
Yes,
different
yes,
strategy.
rolling
Both
update
are.
is different. Yes, yes, rolling update
Okay,
is
okay,
different.
sir.
Rolling updates one by one like that.
Okay, sir.
one by
Under
one. Yeah,
deployment, all these are strategies, sir, like rolling update, recreate, blue green, domain set,
yeah,
right,
yeah.
sir? In the under
Daemon
deployment.
is
Okay.
different. Under deploy, no, daemon set is different. This is
Sir,
different.
okay, okay. Blue greens comes under like a deployment session only, sir. Blue green also.
Yes, yes. Blue green
Mm.
is the stat one of the strategy under deployment.
Okay, sir. Okay. Canary also.
Yeah, Canary also.
Okay, sir. Thanks.
Yeah. Now, before going further to the Canary, let me delete it. Let me show you one tool, okay, which is used to monitor the Kubernetes cluster. Okay. Okay. Let me show you one tool that is called KNS. I already told you to install. This is the KNS. Just like type KNS uh, in your command prompt. This type of UI will be opened. This type of UI will be opened. Now, just click on escape or shift colon, click on shift colon. The search box will be opened like this. The search box will be opened. Now you can see, you can type pods, PO, just type PO, there will be a pod. Just click on enter. You can able to see the what are the pods running, what are its IP address and what's the node IP on which it is deployed, and the age you can see, and whether the status you can see, and the ready, how many are ready, and like that, the pod name, and that such kind of things you can see. And it's a instead of typing commands that we used until now, you can also use this UI to you can see like control D is delete, control like only D is describe, and E is exit, question mark is help, like that, control K is kill. Such kind of things you can do actually with the help of this UI actually. So this is these are latest one. That means recently this is coming. This is used as a monitoring tool in case of Kubernetes. We can monitor multiple clusters in with the help of this KNS tool actually. So this is one way you can, if you want to see the deployment, uh, click on shift colon. Just remember shift colon. Then you will be getting one search box, and what you can type is deploy. That means deployments. The shortcut is deploy. Just click on that, enter that, and you'll be able to see what are the deployments present in our cluster actually, that is. And this is a default namespace. What is namespace we are going to see, okay. And these are the things. If you want to describe the deployment, what is the describe option? Only D. Just click on D. You will be able to describing that deployment. Just escape. And if you want to edit that deployment, click on E. You will be able to edit that deployment, okay. Colon WQ enter, colon WQ enter, like that, okay. This is a tool to monitor to visually monitor the Kubernetes cluster, okay. Now
Sir,
let's
when
go
you
to the
open like a
API.
control D, shift control D, automatically it opens this window, sir. In the in that one, whatever you are showing in the green uh, command prompt, sir. I mean to say, there only
How
we
to
need to
open
run
this?
these commands. Yes, sir.
Yes.
Exactly.
No, no. If you go here, this is a new command
Mm.
prompt I want to say. Just enter
Okay, sir.
knns, okay, after installing,
K
okay.
KNS, sir.
K
K9S. Okay,
K9, yes, just enter.
okay, sir. Okay. Mm.
You will be able to see the UI. That's the command.
Okay, sir. K9S. Okay,
Yeah, this is the one.
okay, sir.
Okay, yeah. Pod is this one. These are the
Uh,
pods. Let me delete the
Hello,
deployment. Yeah, tell me.
Shiva
Hello.
sir, is it this two UI is open source, right? We can download it from
Yeah.
internet. Okay.
Yes, this is open source. You're right.
Yeah, okay.
Yeah. Now go to deployment. Uh, now delete this deployment. Control. One second. Delete deployment default. Okay. Just click on OK. The deployment is deleted. Control D. Okay. Deployment is deleted. And I have deleted this deployment. Okay. And colon SVC. This one. I want to delete the service. Control D. But make sure, see, this is only the kind of UI, but you should also know the commands. Okay. Okay. This is a service. I have deleted all this. You can see the how much CPU is used by the cluster, how much memory, and the such kind of things actually. Uh, Clear. one second. This is UI. Okay, next, what is the Canary deployment? Here I cannot show you in the diagram. Okay, let me show you here itself. Okay, Canary. Let me close this, close this, close this. So this is a Canary deployment. In case of blue-green deployment, what we have used is a different selector, a different selector. Okay, there we have noticed the downtime is there because of the change in the label and selector when the traffic is inside the pod or container, when then the traffic is being consumed. Okay, now here what it will do, there are two types of applications like actual app and the Canary app. That is the actual app with image stable life and Perl, and the Canary app with image nginx colon latest. That means nothing is given, that means it's the latest tag. Okay, now the actual app with the 10 containers, that means 10 replicas, and the Canary app with the latest one is one replica. And if you see the labels, type web app, and the actual app is also a type web app, and the Canary app is if you see Canary service, we are routing the type to web app. That means what it will happen is suppose let me how I can show in diagram. One second. This is the these are pods, one, two, three, like that. 10 pods is there, that is belongs to actual, and the one pod is there in our manifest file that belongs to Canary. And there is a one service which routes the traffic to all these pods. Actually, there's a new pod, the new one also. Now whatever the traffic is there which is coming, which is directly tested on the users, actually the traffic can be routed to this new pod also, this new Canary version also, the old Canary version also. Now in the case of blue green, we separately, our testing team or QA team will be testing the new application. But in case of Canary deployment, this testing will be done directly on the users who are using this application, who are requesting the response from their pods. The traffic which is coming from the users will be routed to any one of these pods with along with the new version also. One, at the initial time, while the new version is first time deployed, that's why we will put only the one replica. That means very less amount of traffic will be routed to this new version, and these are 10 replicas. That means more amount of traffic will be routed to this old version so that the users will not be affected more. Okay, that's the reason. Now what I can do is, let me show you here, like where is that? One second. One second. Okay. Now if you want to quit from this UI, just shift to colon, just to QUIT, quit, just like this. Okay, you will be able to quit. LS or PWD, you can use I'm in the blue grid, cd dot dot cd canary, CANRY canary strategy. I'm inside the canary strategy folder. Clear the screen. Okay, kubectl, once again, apply -f dot. Now to verify the pods, kubectl get pods. Now you can see these pods were of the old version, and the new pods were this is a new pod with new version actually. Now new pod is only one, very less amount of traffic will be routed to this. Old pods are 10, very much amount of traffic will be routed to this, because if there is a bug in the new version of the pod, the user should not be affected much actually. That's the reason why we deploy the old version of the pod more and the new version of the pod very less. And now once they verify the user, when the verification get by the users whether they are able to access the properly or not, after that verification what we will do is just we will decrease the number of pods in the old version to 5 and the new version to 5. We'll increase the new version pod to 5, and what we'll do, we'll just apply that in the cluster. Okay, apply f and dot, and the new version is configured. Now just see, the new version of the pod is going to be increased and the old version of the pod is going to be decreased. Once again, okay. So now new version of the pod got increased and the old version of the pod got decreased. Okay, now after the final verification, what they'll do is they will shut down this old version of the pod. Like they'll make this replica count to 0, and they'll make this replica count to 10, and they will apply funny of dot. Okay, kubectl get pods. So every pod will be running in the new version itself. So in such a way, Canary deployment is designed actually in Kubernetes, or whether see, whatever the types you are deploying, blue, green, or Canary, and whatever it is, it will be present everywhere. But in Kubernetes, in such a way, they will be using, if they use the blue, green, or Canary such deployment strategies. Clear that? Clear, everyone? Any questions here?
Sir, but we need to run the kubectl that apply command again, sir. This one for this one to run the pods again, right, sir? Manifest files for the
Yes,
Canary also.
because
While after changing the replicas, we need to run the kubectl again,
yes, yes,
right,
yes,
sir?
yes, because
Mm.
because you have changed the manifest file. However, Kubernetes know that you have changed the manifest file.
But
You have
sir,
to run.
while changing that one, is it the downtime, sir, or the application can be accessible, or suppose I'm changing like a two manifest files replicas, sir, like a
Mhm.
1, 0 and 10 like that. That time, is there
Okay,
any downtime, sir, for the application, for the users? I
let
mean to say.
let me explain you.
Mm.
1 second. What I can take is this. See, we are not. See, first what we did, the 10 new old pods were running like this,
Yes, sir. Yes, sir.
and the one new
One
pod
new
is
part.
running. One new pod is running. All the traffic is routing from the service to the all the pods like this.
Pods. Yes, sir.
Okay, right, with the new pod also. Now what we did, we have increased this pod count to new pod count to 5. This is actually running. This is already in running
Actually
state.
run.
This is in running
Okay.
state. Okay. We have just increased the number of counts, and what we did, we have decreased this number of pod count
Yes, sir. Yes, sir.
to
Yes.
5. This is a old one. This is a
This is
new
the
one.
new. Yes.
New one. Okay. The downtime that which you are talking, where the downtime will be getting is, suppose we have decreased this one, right, and we have increased this
Replica,
one.
sir.
Suppose, yeah, we decreased this traffic, right, at the to 5 from 10. Remaining 5 pods are there like this. 5 pods are there. Okay,
Okay,
remaining
sir.
5
Okay.
pods got deleted. Okay,
Okay.
the
But still,
traffic which
5
is
parts
already
are
there. No, 5
okay.
pods old one are running. Okay, the new one
Running.
got
Yes, sir.
deleted. The old one, 5 pods are there. Our remaining 5 pods got deleted when we changed this manifest file and applied. Okay, the traffic which is there with these pods, the traffic which is there with these pods already, when we are deleting that pod, that those traffic will be affected. Okay, the traffic which is there, the other pods will not be affected.
Will not be affected.
Yeah,
But
only
application
the
can be
traffic.
running, sir. Okay. Okay.
Yeah, application will be running in all
Running.
states actually. Okay, the traffic only on that pod which got deleted will be affected in such
Will be
cases.
affected.
Yeah, yeah.
But sir, suppose if it is affected, it redirects us to the any other pod, sir. In that case, suppose if a user is accessing this one, suppose he sends the request to the affected pod. In such case, it is redirected to the any working pod, sir, like running pod.
No,
In that
what it
case,
will
only.
happen, user will be getting some error 503. or something.
Okay.
Server side,
Mm-hmm.
internal server error, like this 503 is internal server error, right?
Server, right, sir, right, sir.
Uh,
Mm-hmm.
yeah, internal server error. So such kind of
Mm.
error it will be getting when once, see, this is very
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 minimum time,
minimal
sir.
kind of
Right,
change.
right, right.
Yeah,
Yes, sir, yes,
yeah.
sir, exactly.
If once the user clicks the refresh on the web page, that again traffic routed to the right pod only. It will
Right, right,
not be
pod only.
directly redirected. Yeah, it will not be directly redirected to other pods.
Okay, sir, got it.
Yeah. See, such things will not happen. Okay, this is a very minimal kind of thing actually. So generally, the industry follows recreate only. Sorry, blue like rolling updates only
Tooling update.
until and unless
Okay, sir.
until and unless they have the special use case. So these are any questions, anyone? Okay, these are different kind of strategies that we have in the deployment. Okay, or in which we can deploy our applications on the Kubernetes cluster. Okay, now let's go to the daemon set. This is another kind of workload. Okay, in the workloads we have seen the replica set and the deployment, and let's go to the daemon set as of now. Okay, what is daemon set? Why it is used? Okay, in the cluster we have three nodes like this. This one node, and this is one node, and this is one node. Or we have this is a master node and the worker node. What this daemon set does when we apply the daemon set to the Kubernetes cluster is it applies on every node. One pod of that daemon set will be running every node. If we have 100 nodes, we have 100 nodes. 100 pods of the daemon set will be running in every node actually. That's the daemon set. Daemon set, why it is used? Okay, that is a daemon set. Why it is used? Why it is used is, suppose there are multiple pods running in this node 1 and the multiple pods running in this node 2 and the multiple pods running in this all the nodes of the 100 nodes. The logs from these nodes should be accessed, should be present there, something, right? So such kind of log detection will be happened through the daemon set only. We have something called Elasticsearch. Elasticsearch is kind of collecting logs. Okay, you can visualize the application logs in the Elasticsearch dashboard. Okay, now, with the help of daemon set, Elasticsearch will be getting logs from all the nodes actually. So daemon set will be used to for the collection of logs actually from all the nodes. So that is the daemon set. Daemon set, when we apply the daemon set will be creating a pod on each node. Such kind of Kubernetes object like deployment is a daemon set is one of Kubernetes object. Such kind of Kubernetes object will be used in the log collection actually. So that is a daemon set. Let me show you that in practical. Nothing we can do with daemon set actually. So that is the log type of where is that daemon set workloads. Replica set, this is a daemon set, this is a daemon set. Okay, just I applied, actually this image will be different in case of collecting logs. There will be Elasticsearch or something different image. So but I'm using, just to show you people what's a daemon set, I'm using the Nginx as a thing. Now let me apply it. Okay, ls. Okay, let me delete it first. Kubectl delete hyphen f
It can create any
dot.
number of pods, sir, in the each node also. Any number of pods can
No, no,
exist
no.
in the each node. Mm.
Only one pod in each node.
Okay.
Cd dot dot ls, once again ls, and this is the strategies dot dot slash dot dot ls daemon set, daemon set ls, and let's a daemon set kubectl apply hyphen f dot. Now daemon set is created. Kubectl get pods. Okay, this is a pod, and hyphen o white. Okay, See, this daemon set has been applied to two nodes. These are private IP address of the node. We have two nodes only in the cluster. We have actually three nodes, but two working nodes. Okay, kubectl get nodes. This is two worker nodes which we deploy our applications, and this is the first node on which we deployed. You can see 172.31.43.7 and 172.31.46.107. Okay, you may ask me like why the deployment, like the daemon set has not deployed its pod to the control plane, that means master node. The reason why it does not deploy the pod to the master node is, let me show you, because of kubectl describe node, this one. Okay, something called where is that, taints and tolerations. Yeah, because of taints and tolerations, these are taints that are applied on that node. Because of that, it is unable to know schedule. That means there is a different type of scheduling things are there. No schedule, prefer not to schedule, like that. Such kind of things are there. Let's discuss in the scheduling sections. So because of this taint, that has been applied on the master node, the daemon set cannot be applied its pod on that node. Actually, if we taint our particular worker node also, it will not be applied on our worker node also. Such kind of thing will be going through the in case of scheduling chapter. Okay, that is why the daemon set is unable to apply it on the master node actually. So that's the reason we are only seeing the pods, only two kubectl get pods, only two pods we are seeing. One is on the worker node 1 and the other one is on the worker node 2. That's the daemon set. Any questions with the daemon set, please?
What is the user daemon set? What is the purpose actually? We can apply any strategy, sir. Daemon set can be applied for the any like rolling update, recreate. Any strategy we can apply the daemon set, sir. Blue, green, and
Yes,
canary.
you can you can apply the strategies for also the daemon set, but daemon set mainly
Mm, mm,
used for
mm.
collecting the logs actually. Let me
Okay,
show you
elastic
that
set
dashboard.
only. Mm.
Elasticsearch. Let me show you the Elasticsearch dashboard. Elastic. Uh, 1 second. So such kind of dashboards will be there in the Elasticsearch where the logs will be shown actually. Where is that actual dashboard? It's not getting here. Yeah, such kind of dashboards will be there actually. So we can see the graphs, how many logs are coming at particular time, and how many logs are there at particular time, whether logs coming or not, what is going wrong with our application or not. Such kind of logs will be collected by the daemon set only and sends the logs to the Elasticsearch or Kibana, like that.
Okay, sir. Okay. Only for the log
Yeah.
purpose, sir. Like to collect the
Lo
logs.
Whether it log
Daemon set.
purpose or metrics. Yeah. See, we have
Mm,
two types of things actually. Let me show you in the diagram. Okay. Uh, we have two things in order to monitor the cluster. Okay, one is the logs, other one is the metrics. Okay, where is that? It's not going. 1 second. Okay, one is the logs and another one is a metrics. Okay, logs and metrics. What's the different? What's the difference actually? Logs means it will be getting like once you logged into the data, like when your application is connected to the database, you'll be getting a log connected to DB, like that. When an application is performed something, it will be getting that log there, like that. All the logs will be present in the part of logs actually. Okay, of the application. Now, what is metrics? Metrics is, suppose there is a pod. How much amount of CPU is taking, the pod is taking? how much amount of memory this pod is taking, how many requests are coming to this pod, how many requests are failure, how many requests are 503, how many requests are 403, how many requests are 201, how many requests are 200. Such kind of metrics will be collected as part of metrics. Metrics will be different, metrics are different, and logs are different. Logs are collected by Elasticsearch, and the metrics are collected by Prometheus and Grafana. Okay, Grafana. In case of logs, we use daemon set. In case of metrics also, we use daemon set. Whenever we required one pod on each node, we use daemon set. We have multiple use cases, not only logs. In case of metrics also, you can use daemon set. So that's what I am saying this.
Okay, sir. Okay. If we have like a daemon
Yeah,
set, we can collect like a logs and metrics also, sir. Right?
yeah.
Like, but that Prometheus and Grafana also support should be there, sir, for getting the metrics.
Support means?
And I mean, suppose if I want to get like a metrics of the pods, in such case, we need to
Okay.
configuring like that Grafana also, sir. Grafana also.
Yes. You need to configure Prometheus and Grafana within your cluster.
Okay. Sir, you are going to show
So
that
that
one
you
also, sir, in this one, Prometheus and Grafana also.
no. Actually, see, if time
Mm-hmm.
permits, I can show everything, whatever logs or whatever Grafana and Prometheus. But we have
Mm.
much syllabus actually. If you see the syllabus, we
Okay,
are
sir. Okay.
just here only. Okay, we have much
Mhm.
syllabus to complete. If the time is there, I can show you. It's just a configuration only. Okay, so that one I
Mm.
cannot say prior. Okay,
Okay, sir.
okay, that's the thing. That's the thing. Now what we can do is the other thing is the job and CronJob. Let's go to this actually. What is job? Okay. Now, what is job? Job is nothing but there will be some services like what I can do, what I can say. It should run only once actually. In Kubernetes cluster, there will be for our requirement there will be some things. It should be only running once time. What example I can take is okay. There is a there should our Kubernetes cluster should send an email to me. It should be happened only once. Once the email has been sent, it should shut down this pod. Okay, why this pod is required? Okay, such kind of the things which need to be done only once in the Kubernetes cluster that will be handled by jobs. Actually, jobs are nothing but it's one of the Kubernetes object which is used to handle such kind of workloads. Actually, that should be done only once. Okay, the other example is I can say is the backups from the MySQL pods. These are the MySQL pods or MongoDB pods. The backup should be done only once. So in such cases, you can do the in such cases you can configure job and you can do the backup to your selected folder or somewhere. You can do that. And these are the jobs. Whatever the things that you want to do only once, and after that it should be shut down. That is called a job. Okay. Now, in case of backups, suppose we will be running our Kubernetes cluster 365 days actually. But backup, if you take only once, that is not required actually. That should not be taken only once actually. Backup should be taken daily actually. Daily at what time you want to decide that one. Daily morning 8 o'clock. Okay, not daily morning 8 o'clock I want to take a backup. But if you can't do manual backup, that's a kind of manual thing. But in an automated way, you have something called CronJob. CronJob will be, if you configure CronJob in your Kubernetes cluster, that will be taking the backups of our pods in a regular intervals, whatever the uh, you'll be giving something called cron expression within this configuration file of the cron job, and based on this cron expression, that will be taking the backups in regular intervals of time from our MySQL or MongoDB clusters, MongoDB pods actually. So that is called cron job. So job is nothing but if you want to run a particular task only single time, that is job. But if you want to run a particular task in regular intervals of time, that is cron job. Actually, that's the difference between the job and the cron job. Let's go with the practical. Okay. Mm, kubectl get daemon set. This is a daemon set we just applied. We'll delete this kubectl delete -f kubectl delete daemon set, right? Okay, daemon set deleted. Kubectl get pods. Okay, cool. So these are the pods. Okay, clear the screen. Okay. Now, if you see the jobs, if you this is a job spec. This is a job spec which I have already created. Okay. Let me explain this. This job belongs to the API version batch/v1. It should be this one. Okay, this kind is job, and the metadata is under that name is this. I given some name, and the you need to give template and spec. Okay, containers. What's the job name? The container name is my job, and just I have took the Ubuntu image. I'm executing this command. Okay, I'm executing this command like sh-c sleep 10 seconds. Okay, now let me comment out this. Okay, let me comment out this. I'll explain what is this and what is this active deadline seconds and completions and backoff limit. Once I applied this job into the Kubernetes cluster, this is a restart policy should be there. That's never. I hope you people know what is a restart policy. Okay, now backoff limit. Okay, backoff limit is for what is this backoff limit? Let me explain you after the applying in the Kubernetes cluster. Actually, let me save this file. Okay, now go to pwd and in the daemon set cd jobs. Let me apply it. kubectl apply -f job spec.yaml. This is the one I have applied the job. kubectl get job. Now the job is has been applied. When you create a job, kubectl get pods. Once again, a pod will be created. Okay, see, you want to perform a task. You need to send an email. Okay, that's the reason you have created a job. This is a job. This job, what it will does is internally it create a pod. Okay, that is this pod actually. That is this pod. Okay, this pod completes the task which we are given. What is the task we are given? Is the sleep 10 seconds. Just it's a simple task. In real time, what it will be, what they will give, I'll show you in the I'll show you in the diagram. Okay, but we have given the simple task like just sleep for 10 seconds, and uh, and that has been executed, and you can see the status and it is in completed state. Okay, now kubectl get job. You can see one out of one job is been created and one job is being completed, and it's completed within like 15 seconds, and this is a job. Okay, now what is this? This is a job actually. This is a meaning of job. What is this backoff limit? Backoff limit 4. What is this? Let me give the wrong. Let me explain the diagram first. Okay, 1 second. Okay, let me explain here. Backoff limit. For example, let's take 3 only. Okay, what it does actually. Now we have created a job in the Kubernetes cluster. This job internally creates a pod. Okay, if this pod succeeded, succeeded. Let me Don't mind if the spelling is wrong. Okay, if this pod succeeded, it will be going to other state. If this pod does not succeeded, no, not succeeded, and it will be creating another pod within 3 times. First pod failed, and it will create the second pod. If the second pod also failed, it will create the third pod. If the third pod also failed, it will make the something called back of limit exceeded error. So this kind of error you will get if the number of specifications, like if you have specified the back of limit as only 3, that's why it will create the pod. If the failure happens, it will create the pod only 3 times, and if that also reached, it will throw something called back of limit exceeded. That's a that's a meaning of back of limit colon 3. Let's see that practical. Okay, now what I will do, I'll give the wrong command. Sleep. I'm giving the wrong command here. Command is wrong. Now I'll apply this. Just I'll give only 3 for timing savings, and kubectl get job. Now I want to delete this job. Just delete this job. I have deleted. This verifies. No jobs are there. Kubectl apply -f dot. I have applied that job. Now kubectl get pods. Now you can see first pod has been error, status is error, and kubectl get job. You can see completion is 0. It takes some time to complete that. Its second pod is also error, and it has created second pod because of we created back of limit to 3. We have put that. So get pods. Let us wait some time. Yeah, its third pod has been created, and it will also be in error state. Now just kubectl get job. All the 3 pods got created as our expectation. Copy it. Copy the job name. Kubectl describe job and the job name. 1 second. It should show that kubectl it's taking some time. Get pods, or let's describe this. Let's describe this also. Let's see there. Describe pod and this one, and 1 second, it will show get describe job. You can see back of limit exceeded error. This is the type of error that will be helpful in your debugging. If the job has been failed with this error, that's because there is some mistake in our task that we are doing. Okay, that's the reason that will get that's the reason that we are going to get in this case back of limit exceeded. This is one of the commonly occurred error actually. So in the Kubernetes, okay, clear the screen. This is a back of limit exceeded error. Okay, now what is this completion? So let me make this right. EEP. Okay, what is this completions? Or before going to these completions, okay, let me
Back
go
of
to
limit
this
means it
active.
create like a till 3 pods only, sir, if the pod is failing, right, sir?
Yeah, yes, because we have only specified the back of limit to 3.
Why it is failing, sir, actually, the pod, why it is failing, sir, actually, the reason, anything we...
Yeah, the reason we have given the wrong command here previously. Just wantedly we given.
Okay, sir, okay. Yeah. Wrong command in
Yeah,
the...
wrong command. Yeah, wantedly to see this error we have given actually.
Okay. Then 3 times only
Yeah,
it trying to create it.
it 3 times only it will try to create. See, if you
Otherwise, sir,
don't,
it continuously
yeah,
tries, sir. It continuously
no,
tries. Suppose it...
no, If you don't specify this backoff limit, the default value is 6.
6. Okay, sir.
Yeah. If you don't specify, that is 6, and if you specify, you can, that's the custom value, you can do that. Okay, now what
Okay,
is
sir.
the active deadline seconds? What is active deadline seconds? Okay, this is one of the error you will be noticing in the real time also. And what this active deadline seconds is, see, we are expecting, 1 second, let me show in the diagram. We are expecting there is a job and there is a pod has been created. We are expecting this job to run only 10 seconds, but this pod is taking more than 10 seconds. That means greater than 10 seconds. Now, what is this active deadline seconds says is, if it takes more than 10 seconds, then deadline exceeded error will get. We'll get this kind of error. Let me show you. Okay, there is a sleep command. Okay, I want to sleep for 30 seconds, and now active deadline seconds, I'll be making only 10 seconds. That means my job should be completed, my task which I'm performing here should be completed only in 10 seconds. If you take more than that amount of time, then you should be able to see deadline exceeded error. Let me apply it. Okay, one second, I make the spell wrong. One second. Delete job and job name, let me delete it. Okay, okay, clear the screen. Once again, dot. Now job has been created. kubectl get pods, and job has been running. kubectl get job. Now you can see pods terminating, and one second, completions. And when you describe it, it will take some time to display that error. Let's describe whether it came or not. kubectl describe job sleep. You can see deadline exceeded error actually. So that's a job was active, no longer specified deadline is that, see, here the deadline we specified is only 10 seconds, but my sleep time is 30 seconds, and that the sleep time exceeds the deadline seconds. That's why we are noticing this error, deadline exceeded error. This is also common error that you notice in your uh, real environment. What's the thing is, if the specified script that we specified it here takes more amount of time than the active deadline seconds, then will this error will be thrown like deadline exceeded error. Actually, if you get the job, there will be a no completions because that has been errored in error state actually. So that's a thing. This is a reason why we are getting this deadline exceeded error. Okay, let me comment out this number of completions. Okay, let me comment out this, and let me make this as 5 seconds. And that's the reason. Okay, now what is this completions? What is this completions actually? Completions completions means after how many number of successful completions this job is stated as completed. Such kind of thing is completions actually. Suppose, let me apply it. Okay, clear the screen. Okay, kubectl job sleep-job. Okay, this is job name. Okay, now kubectl get pods. One second, kubectl apply -f dot. Now kubectl get job. Now job has been created. You can see previously we are seeing only one completion. Now you can see the three completions. It is expecting three completions because after this many number of successful completions only we need a status that it is completed state. But after that only, because such type of scenarios also there. Now you can see kubectl get pods. You can see all the three pods got completed. All the three pod status, it will create three pods, and three pods got completed status. Okay, kubectl get job. So you can see 3 out of 3 got completed. That job is stated as completed. Let me show you. Okay, kubectl describe job, and this one, and you can see where is that. Yeah, you can see it here, normal, and it's been completed state. Okay, that's a thing, the meaning of completions there. Actually, these are the configurations that you can give in job spec, and how the people use in the real time. Let me explain that these jobs. Okay. Mm,
Sir, if it is the deadline time limit less than more than the
mhm.
sleeping time, sir, then it's fine, sir, right?
Deadline time limit is less than the sleeping time.
Less than the sleeping time, then it will fail, sir, right?
Yes, then it will fail. If the deadline
Mm,
time seconds is
mm.
taking more than the sleeping time, then it will success.
Success. Only it can be applicable only the job only, sir. Kind job only, job related things
Yeah, yeah,
only,
yeah, yeah, yeah.
or even pod also,
It's
any pod like
no.
Nginx.
It's
Mm,
no, it's specification of job, because the Nginx will be
mm,
continuously running. It's a not a single time job actually. Okay,
mm,
job we are
mm,
only using to run a specific task at a particular amount of time. A particular event has happened. This job should
mm,
run. So such kind of
mm,
time only we are using the jobs. But Nginx is an application.
mm,
It will be
mm.
continuously running actually. In such cases, we don't use jobs, and it will not be
Okay.
this back off limit and will not be configured there.
For the okay Nginx.
Yeah, Nginx kind of pods and deployments cannot be configured
Only
there.
in case of a job only we can use like this
Yes,
exceeded.
yes,
Okay.
yes, 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 yes. And now how the people uses in real time. Okay, now how they use is like this. Okay, one second, let me take this one. Okay, now they'll be writing some script in their local laptop, whether it's a Python script or the shell script or any other language program. Okay, any other program they'll be writing. Okay, what they'll do is, with this script, they'll make this Docker file that we have seen. They'll make this script included in the Docker file, and with the help of Docker file, they'll create Docker image. Okay, they'll create Docker image. This Docker image is pushed to Docker registry, and this is a Kubernetes cluster. They will pull that image from the Docker registry with the help of job. They'll create a job, and they will the job will be creating a pod. And in the job spec, what they'll do, they'll give some command. We have seen there will be a command. There is a command in the job spec, and they'll be giving suppose it's a Python script. They'll be giving like this Python. It's like Python. Python 3 is a, if you use Python 3, this is a command Python 3, and inside the container where the Python 3 exists, where that script exists, is slash etc slash script slash email dot py. They will give like this. in the command. Where is this command? This command is here. Okay, these are, let's suppose these are image that the users created in this case. There's a people created in this case, and they'll execute this Python script, and in such way they'll be using this job. Actually, first they'll be writing script, and they'll be making Docker file, which is included. Script is included in this Docker file, and they'll make Docker image, push to Docker registry, and they'll create a job with that image, and they'll run this Python script. Such kind of thing they'll do, or else they can also write script here in the place of command. Multiple ways you can do. Generally, people does like this. So this is a way. So this is a job. Okay. Any questions today, please? Actually, it's time.
This one Docker image is created, sir. Then they are using like this command in the pod in the job.
Yeah.
So
In the job spec, in the job spec.
okay, sir. Okay. Okay, in the job. So what is purpose of this one, sir? It's execute in the particular time, sir, like a scheduled time, right, sir?
No. Schedule time is cron job. Okay. This will be
Uh,
executed when the job is created. Okay. If you configure cron job, it will be
mm,
executing at particular time. Actually, they'll use in the cron job this one, but
mm,
this is how they use in the job. Actually, I mean to say, this is how in the real time it will be there. It will be configured. They'll be using some
mm,
shell script and making the Docker file and Docker image, and using, they'll pull the Docker image and execute that script actually. Or you can also write
mm.
the script here at the place of command. I have written simple sleep, right? You can also write the script here if you don't
Okay,
want
sir.
to create a
Okay.
Docker image and all. Yeah.
Mm. But cron job for a particular schedule time, sir. That is okay.
Yes. A cron job will be a particular schedule time. You should write
Mm,
something called cron expression. Uh,
mm.
Based on that cron expression, the cron job will be running state.
Cron job will
At
execute.
particular. Yeah.
In that case, kind cron job, sir. In that case, in the pod,
Yes.
that cron job,
In that case, it's a cron job only. It's a kind is cron job. This is a
cron job
cron
only. Okay,
expression.
expression.
This is a cron expression. Yeah, this one
Mm-hmm.
you'll be
Sir,
seeing
why
tomorrow.
we need to go for like a job, sir? Actually, we can do like a some pod only, na, sir. Why we need to create cron job, fine, sir. But whereas like a job session,
Hmm.
what is the any other
See,
benefit, sir? Mm,
no. See, if you
mm,
want to deploy your application, this is a, one second. This is your application which you have created, and if you want to deploy this application, okay, in the Kubernetes cluster, you should create a pod, because pod is a continuously running thing. But
yes, sir. Okay.
job is not a continuously running thing. Okay, once whatever
Mm,
the task we specified in this job will be executed, and this pod will be in completed state. Actually, in such cases, you need to use job. Okay,
okay,
a
sir. Okay,
particular
okay.
task has to be
Mm-hmm.
done. Okay, but
Mm-hmm.
in if your application should be there, that is, in that case, you need to use pod. You cannot use if you want to use job, you cannot use pod. Okay, pod is continuously running state. Okay, it will be,
Mm-hmm.
it's a
Okay,
continuous
sir.
running
Okay,
thing
sir.
actually. Yeah.
Okay, pod is continuously, but job is after completion, it is completed state, sir.
Yes. Oh, a particular task, if you want to run,
Mm,
that's a job. Okay, but if you want to run
mm.
your application, that's a pod.
Okay, sir.
And hello, sure, sir. What would be the trigger point? I mean to say, see, in this case, if we have written a job which will trigger a email,
Hmm.
email once, email notification to stakeholders or any particular user. So if
Okay.
we and we wanted to, we want in the manifest file, we want to put a condition where if this task is completed, then only email notification will be sent.
Okay.
So let's say some secret and password needs to be emailed once user are created. So
Hmm.
where we have to specify that condition, because every
That
time it should not shoot up a mail, right?
Yes, sir, you are right. That condition which you are going to specify should be specified in this script which you are mentioned here. See, suppose
Okay.
let me tell you. Suppose this is an application pod. Okay, suppose let's think this is an application pod, and this has written some data to MySQL. This is a MySQL table. I hope you people know what is MySQL and how the
Yeah.
data is written here. This is MySQL table. This application has written some entry here. This first entry is already there. This is second entry, which is newly written by this application. Now job has to see this when the particular entry has been happened, the job has to execute actually. In such cases also you can use job and to send an email. This condition you need to give in the script actually. What the script you are going to mention here in the command. If the new entry has been happened in the database, then this should execute. Such kind of also you can give in the command.
Yeah. Okay. Got it, Satya.
Yeah.
It's like a one-time
Any
activity,
question?
sir. Just like, right, sir?
Yeah, it's a one-time activity.
Mm.
It's actually this job. This is also a cron. It's a one-time activity, but cron job is scheduling activity like
Mm. Yes, sir.
once
Yes, sir.
every time,
Mm.
every minute, once every day, once every year, like that.
Particular time,
Okay.
particular day. Yeah.
Yeah, like that. Job is a one-time activity. Any questions? Anyone, please? Before today? Okay. Actually, I'm designing an application. Let me mention this. Where is that? Let me. Okay. I cannot show now. One second. This is an application I just recently created, which connects to MongoDB. Okay, which connects to MongoDB database, and we are going to do the project with this actually. After completing the workloads and the configuration sections, we are going to do this project. I have created a simple two APIs, and it's a kind of student application. I've created two APIs, which stores the data into the database and which gets the data from the database. It's a simple application just to as an example. It's a project kind of thing, but you don't need to worry about this application. We are going to make this Docker image and deploy the Kubernetes cluster. How we are going to take the backups from the using statefuls and deadly service. We are going to see. Just I'm mentioning this. So we are going to do some project like in the future. Yeah. If there is no questions, we'll quit today and we'll meet tomorrow. Thank you. Thanks everyone.
Thank you, sir. Thank you.
Thank you. Yeah, Deepak, actually, I'll be sharing the manifest files. No problem with that.
Yes, sir. Yes, sir. Yes, sir. Can you share all the manifesto?
Yeah, actually, until yesterday, I shared all the everything. I think Sunday itself, I have shared whatever the things we have discussed. I'll be sharing the remaining things soon, actually. Manifest files. It is taking for me time to create a document because I need to concentrate on my office and this one, right? So sorry for that. Sorry for the delay, but I'll be doing that soon.
Okay, sir.
Yeah, thank you. Thanks everyone.
Thank you,
We'll
sir.
meet tomorrow.
Thank you, sir.
Yeah, thank you.